Today, we're going to implement a basic anomaly detection algorithm using the isolation forest on a synthetic dataset. Let's get started. First, let's import the necessary libraries. We'll need NumPy for numerical operations, pandas for data manipulation, and scikit-learn for the machine learning model. Isolation forest class from scikit-learn is the core functionality we'll use for anomaly detection. Matplotlib helps us create visualizations like scatter plots, which will be helpful for displaying our data and the detected anomalies. Next, let's generate a synthetic dataset with some anomalies. The seed function sets a random seed for the NumPy random number generator. This ensures that whenever we run the code, we'll get the same random data, useful for reproducibility. This line generates a random dataset, X, with 100 data points and 2 features each. The values are drawn from a normal distribution with a standard deviation of 0.3. Here we are creating another dataset, xtrain, by shifting the existing data, X, in both directions by 2 units on each feature. This represents our normal data points. Finally, we are creating a separate dataset, xoutliers, with 20 data points scattered uniformly between -4 and 4 on both features. These will represent the anomalies we want to detect. Now, let's combine the normal data and anomalies into a single dataset, X, and then display a preview of the first few rows. Here's the breakdown. This line combines the normal data, xtrain, and the anomalies, xoutliers, into one dataset, X. This is the complete dataset we'll use for anomaly detection. Here we convert our data, X, into a pandas data frame, df, which is like a spreadsheet. It also assigns meaningful names, feature 1 and feature 2, to the columns. We are printing the first few rows of the data frame, df, giving us a glimpse at the data points and their features. The output shows the first 5 rows of the combined dataset, X, which contains both normal data points and anomalies. Each row represents a data point with 2 features, feature 1 and feature 2. The values in these columns correspond to the coordinates of the data points in the 2D space we'll be visualizing later. The normal data points are clustered around coordinates 2, 2, and -2, -2 on the plot, while the anomalies are scattered more widely across the space. Now, let's create our isolation forest model we'll use for anomaly detection. Isolation forest specifies the type of model we're creating. Contamination equals 0.1 tells the model that we expect roughly 10% of the data to be anomalies. You can adjust this value based on your specific dataset. Random state equals 42 sets a random seed for the model, ensuring consistent behavior when we run the code multiple times. Now, let's train our model on our dataset, X. This step involves building the decision trees that make up the forest and learning the patterns and characteristics of the normal data. With the model trained, we can predict the anomalies in the dataset. Here we are using the trained model to predict whether each data point is an anomaly or not. Here's what happens. This predict function applies the model to each data point in the dataset, X, and stores the predictions in ypred. We are printing the predictions. The output will be a list of values, where 1 indicates a normal data point and -1 indicates an anomaly. In the output, we can see the predictions made by the isolation forest model on the combined dataset, X. Each value in the list corresponds to a data point. A value of 1 indicates that the model predicted the data point to be normal, while a value of -1 indicates that the model predicted it to be an anomaly. Based on the output, you can see that the model has correctly identified several of the anomalies that were artificially introduced into the dataset. Let's visualize the dataset and highlight the anomalies. Here we create a scatter plot to visualize the data and the detected anomalies. This code will plot all the data points from X. The output visualizes the data points and the anomalies detected by the isolation forest model. The plot has feature 1 on the x-axis and feature 2 on the y-axis. In this plot, the normal data points, we can see that they cluster around 2 specific points, 2, 2, and -2, -2, represented by white circles. This means that many of the normal data points have values for feature 1 that are close to 2 or -2, and their values for feature 2 are also close to 2 or -2. On the other hand, The anomalies are scattered more widely across the graph and appearing as red circles are easily distinguished from the normal data. This means they don't cluster around any particular points. Their values for feature 1 and feature 2 vary more randomly, making them stand out from the normal data points. Think of it like this. The normal data points are like a group of people standing close together in two different corners of a room. The anomalies are like a few people scattered throughout the rest of the room. And that's it. We've successfully implemented a basic anomaly detection algorithm using the isolation forest on a synthetic dataset. Thank you for watching, and don't forget to like, share, and subscribe for more coding tutorials.